In this video, we're going to look at moles. Now, moles are not as scary as students think they are. A mole is just a number. So my example for this is you all know what the word 100 means. It means 100. You all know what the word 1,000 means. It means that number. Million means that number. Billion means that number. Mole means that one. So yeah, it's not as nice a number. It's clearly massive because I've had to put it in standard form, but it is just a number, just the same as 100,000, million, billion. Now, the reason it's such a weird number is because, well, it's really useful in chemistry. It is the exact number of atoms in 12 grams of carbon or in 24 grams of magnesium or in 73 grams of germanium or in 96 grams of molybdenum. That number has been chosen because it is the exact number of atoms in exactly the mass number in grams of any element. So you can name any element on this periodic table, and I know the mass of 1 mole. Iodine, 127 grams is 1 mole. Platinum, 195 grams is 1 mole. Helium, 4 grams is 1 mole. That number's been chosen to fit that pattern. Now, what that does is that leads us to an equation. Now, that's the equation as a triangle. You've been shown it by your science teacher. Just writing it not as a triangle, so mass in grams is formula mass times by the number of moles. Now, that fits in with exactly what I've just said. So I can still see platinum on the screen. So 1 mole of platinum is its formula mass, 195, or atomic mass, 1 times 195. So its mass in grams of 1 mole is 195. So it's a lot easier probably just to memorize this equation. You will not be given it. So memorize the equation or remember that the mass number is the mass of 1 mole, and then you'll be able to approach these questions. So let's have a look at some questions. So this one, I believe, was just a quick question on a paper to add in a couple of marks. Amount of substance can be described in different ways. Complete the sentences. 1 mole of a substance is the relative formula mass in grams. So all those relative formula masses and atomic masses I was highlighting in the periodic table, well, it is 1 mole in grams. The relative atomic mass of an element compares the mass of an atom of an element with the mass of an atom of carbon. Chemists always compare everything with carbon. But let's look at calculations. That's what most people have been asking about. So in this question, we're asked to calculate the number of molecules, not the number of moles. But I have to find the number of moles to do that. Now it's also asking about carbon dioxide. So I have to know that carbon dioxide has the formula CO2. 1 carbon atom, 2 oxygen atoms. Now I said I'm going to have to find the number of moles, so let's write my formula. Mass is formula mass times the number of moles. So I've got a mass, I've got 14 grams. I need to find the number of moles, and I've not got my formula mass yet, so let's work it out. So this is my formula, CO2. I know the carbon atom has a mass of 14. I know an oxygen atom has a mass of 16, and there's 2 of them. So 2 oxygen, so my formula mass is 46 when I type that into my calculator. So my formula mass is 46 grams. That is the mass of 1 mole. I'll put it into my equation, 46 times the number of moles. Now I need to rearrange my equation. At the moment, n is times by 46. To get it on its own, I need to divide by 46. So I'm going to do 14 divide by 46 to get the number of moles. So typing that into my calculator, I get 0.30 and a load of other numbers. They've only given me two significant figures, so I'm going to do the same. Now that's the number of moles. Now at the moment, I've already gained loads of marks. I've worked out a relative formula mass. I've put numbers into correct equation. I've rearranged. I found the number of moles. I've got 3 out of 4. But I was asked for the number of molecules. I've got 0.3 moles. This is where I need to remember what is a mole. I need to remember that horrible number. So to get the number of molecules, I take the number of moles and times it by the number of atoms in a mole, or the number of molecules in a mole. Now, I am going to have to type a number that's standard form into my calculator. So I'm going to type in 0.30 times 6.02. Then I'm going to use the standard form button. The standard form button's at the bottom next to answer, and it just looks like times 10 to the x, and that's the button I'm going to press for the standard form button. So press the standard form button and then 23 for the power. Equals 1.81 times 10 to the 23. My calculator gave the answer in standard form. I've written my answer in standard form. That's the 4th mark. Let's look at another one. So in this one, a bag of fertilizer contains 14.52 kilograms of ammonium nitrate, and we've got the formula for that. The relative formula mass is 80. Calculate the number of moles this time, and we need to give our answer in standard form and to two significant figures. So I'm going to write out my equation again. Mass is the relative formula mass times by the number of moles. So my mass is 14.52 kilograms. My relative formula mass is 80, but remember, that's 1 mole in grams. So I've got a mismatch of units here. I need to turn grams into kilograms. Now, grams are a lot smaller than kilograms, so I need to divide. So I'm going to do 80 divide, and kilo means 1,000. So I'm going to do 80 divided by 1,000. Typing that into my calculator, I get 0.08. That is what's going to go in here, 0.08 times n. Now, before I carry on, I could have done it the other way around. I could have turned this into grams and put that in grams there. Either way doesn't matter as long as my units match. So I could have put that in grams and left that in grams, or I can have them both in kilograms. It doesn't matter which. Now I can rearrange my equation to find the number of moles. So I've currently got times 0.08. So I'm going to divide by 0.08 to get rid of it. So 14.52 divide by 0.08 is the number of moles. Type that into my calculator and I get 181.5. Now I was asked to give my answer to, first of all, in standard form and then to two significant figures. So standard form, I need to use the first number, then put a decimal point, then the next numbers, times 10 to the power, and then I need to have to work out how far I've moved my decimal point. So 1, 2. So that's in standard form. Then it asks for two significant figures. So I need the first two numbers, 1.8, I check the number after, which is a 1, so I don't need to round up. So it's 1.8 times 10 to the 2. And that's my final answer. Remember, I've got marks all the way through that. I've got marks putting numbers into the equation. I've got marks for changing units. I've got marks for standard form, marks for significant figures, and there's all my marks. Even if I forgot to change the units, I could still get marks for significant figures and other parts of the question. Let's see if we've got time for one more. So this one has quite a bit more to do in it, but it's the same thing. So another method of extracting copper from low-grade ores is bioleaching. A solution of copper sulfate produced by bioleaching has a concentration of 0.319 grams per decimeter cubed. We're given the relative atomic masses and the formula of our chemical. Calculate the number of moles of copper that can be produced from 1 decimeter cubed. So first of all, I'm given a concentration. If I'm given a concentration, I'm probably going to need the concentration equation. So I'm going to do concentration is mass divided by volume. The concentration is 0.319 equals mass, which I don't know, divided by volume, which is 1, which I'm given. Now I can rearrange. It's currently mass divided by 1, so I'm going to times by 1 to get rid of it. 0.319 times 1 is the mass, which I don't need a calculator for, 0.319. So I've now got my mass. I now understand why I needed my mass, because I'm trying to find moles and masses in the moles equation. So if I write my moles equation, mass is formula mass times the number of moles. I've got the mass, 0.319. Right, I've not worked out the formula mass yet. So I'm going to work out the formula mass. I've got CuSO4. So I've got 1 copper, which is 63.5. I've got 1 sulfur, which is 32. And I've got 4 oxygens, so I need 4 lots of 16. And that's going to get me my relative formula mass, which if I work all that out on my calculator is 159.5. So now I've got my formula mass, which is this one. So 159.5 times the number of moles. I'll rearrange to find my number of moles. So it's currently N times 159.5. So I'm going to divide by 159.5 to get it on its own. Type that into my calculator, and it's going to be a small number. My calculator is telling me 2 times 10 to the minus 3. And I'm allowed to leave my answer in standard form. So that one had an extra part with that concentration given as well. But ultimately, it was the exact same process. Find the formula mass, find the mass, rearrange for the number of moles. So I hope that helped with mole calculations.